Hello friends, welcome back. Here in this video, I am going to solve one question related to moment. This question is very helpful for 10th class, 11th class, 12th class students and students who are pursuing in BTech mechanical discipline, and also the students belongs to diploma in mechanical engineering students. So let's continue. Question says, find the magnitude and direction of a single vertical force P. Single and vertical force P to be applied at point C as shown in the figure so as to make the resultant of the entire system pass through A. Okay, now O A B C is a system. There is a system like L shape structure is there, having different portion, and at different portion different types of load are acting. At point O, as we are observing here, at point O 100 Newton force is acting upward direction. At point A, at a distance of 10 centimeter from O, 400 Newton is acting vertically downward. At point B, one external moment is applied here of magnitude 25 Newton meter, and below it 15 centimeter leg. At point C, one vertical upward force P and one horizontal 300 Newton magnitude force is acting at point C. So we have to find the magnitude of this force P, and so as to make the resultant of the entire system pass through point A. It means what? There is a point A at which the whole entire system resultant magnitude moment is passed through this value at point A. This question is saying, now, so to find the value of magnitude and direction of the single force means what? We have to find two things for this P. One is magnitude and there is direction, Two things we have to find: magnitude of this force P and the direction of this force P. Secondly, also find resultant force means what? Here vertical force, here horizontal force are acting. So to find the resultant, we have to approach like this. See, first of all, we will see how much amount of force P is acting and where, either vertically upward or downward. So according to the question, it is given vertically upward force P is acting. So now while following the direction of P acting vertically upward, we will take total moment of this force about this point A and equate it to 0. Why? Because the system is in equilibrium. So we can say, since system is in equilibrium, therefore summation of all moment about this point A must be equals to 0. System is in equilibrium, it means there is no rotation, there is no rotation taking place here about this point A. So we can say, see, 100, I am considering clockwise moment as positive and anti-clockwise moment as negative. Okay, so now at point about this point A, 100 Newton force is acting. So 100 Newton force will produce an clockwise moment. So we can take clockwise moment as positive. So 100 into perpendicular distances. See, 25 Newton meter is acting. This is an external force. This will also external moment. This will also consider as an external moment about this point A. So this is Newton meter. So here distance is 10 centimeter. It means 0.1 meter. 20 centimeter means 0.2 meter, and 15 centimeter means 0.15 meter. So I have already converted this length into meter. So as to take the moment about A is A in easy way. So we can say 100 Newton multiplied by perpendicular distance will give the clockwise moment, which is I am considering here positive about this point A. So 100 into 0.1. Okay, now this 400 Newton is passing through the moment center. There is no effect to produce any types of moment. So one external moment clockwise is 25 Newton meter. So we can add here directly 25 5. Now one more thing, 300 Newton. First P force is acting. While acting at point C, it will produce about this point A in anti-clockwise. So we can say minus, because anti-clockwise I am taking sign convention as negative. Anti-clockwise moment P multiplied by perpendicular distance. How much about this? This is the line of action, and what is the perpendicular distance? 0.2 meters. So we can say minus P into 0.2. And now one more force, that is 300 Newton. What is the perpendicular distance? So if we are proceeding in backward direction, this is what line of action of this 300 Newton force. What is the perpendicular distance? This is what? 0.15 meter. So it will produce, see, line of action is this 300 Newton, and what is the perpendicular distance? This is the perpendicular distance 0.15 meter. And which type of moment, that is clockwise or anti-clockwise moment, is produced by this 300 Newton? So see, if I am pointing at this point, holding this point A and making like this, then it will produce an anti-clockwise moment. So 300, so anti-clockwise moment negative, minus 300 into 0.15 is the perpendicular. This value will be 0. Okay, now so while transposing this, because it is an unknown quantity, so we have to find the value of P. So I'm taking transposing to right hand side, then it becomes, so we can say 10 and 100, this 00, this 10 cancel out. So 2 upon 5 P, it means what? 10 plus 25 minus 3 into 15, that is 45, minus 45 gives 2 into P divided by, yani 2P divided by 10. Okay, now so 10 plus 25, that is 35, and minus 45, which will give minus 10, is equals to 2P divided by 10. Okay, my cross multiplying, so 10 into 10, 100, minus 100 divided by 2, that is P equals to minus 50 Newton. Okay, minus 50 Newton. So this minus 50 Newton here figure says that P is acting vertically upward, and this minus indicates that considering the force which is acting upward direction is wrong. So actually on the system, if P will act in vertically downward direction, then the system would go into equilibrium. So we can say therefore P, its magnitude, this is what? Magnitude is equals to 50 Newton, but in what? Downward direction. So this is what? The magnitude. And now magnitude we have obtained. Okay, now so we will take overall here at this point we can say resolve total for the system, resolving total forces, summation of all forces along x-axis. Okay, that is x-axis here is positive I am taking, and positive y direction if I am taking positive. So total forces, how many forces along x-axis? 300 Newton is acting along x-axis, and no more forces is acting in this direction. So we can say 300, and it is acting positive direction, so we can say 300 Newton. Summation of all vertical forces along or in y direction, along the y direction. So one more force is P, one force is P, whose value, if I am taking upward direction, then its value is minus 50. Now one force is 100, again it is also acting upward direction, so it is taken as positive, and 400 is downward direction, so minus 400 we can say. So 100 and minus 400 minus 450 minus 50 minus 450 plus 100, that is minus 350 Newton. So this minus indicates overall the value of all resultant forces will act in downward direction. So actually we can say summation of all forces along y-axis is nothing but 350 Newton, but downward. Okay, now if I am taking here 350 Newton y along y-axis but in downward direction, and 50 Newton downward direction, no, summation x-axis 300 Newton in this way, 300 Newton. Okay. So now overall its resultant would be let R. So R is nothing but summation of fx square plus summation of fy square and its square root. Put the corresponding value. We can say 300 its square plus 350 its whole square. And I'm using calculator to calculate it. 300 its square plus 350 its square root of this will be 460.977 Newton. This is what resultant. So one more answer we have got, another resultant, and let alpha is the angle made by this resultant with 300 Newton. Let alpha angle made by resultant R with 300 Newton. So tan alpha we can say, so vertically direction 350 Newton is acting, so 350 perpendicular divided by base, that is 300. So alpha becomes tan inverse. If I am transposing this tan, then 350 divided by 300. Tan inverse 350 divided by 300, 49.398 degree. So this is what direction. So we have magnitude of P, we have magnitude of resultant R, and we have the direction of this resultant by making an angle of 49.398 degree with 300 Newton. I hope at the end, this is very clear. So at the end, if you find my video very helpful, you also like, comment, subscribe our channel and share it among your family and friends. Thank you for watching my video.